You're 35,000 feet in the air. You flush the airplane toilet, and that sound happens. That incredibly loud, almost violent suction sound, like the plane itself just gasped. It's nothing like your toilet at home. There's no gentle swirl, no familiar splash of water refilling the bowl. It's a blast of noise, and then nothing. The waste is just gone. So where does it actually go? Is there really a tank back there that gets dumped somewhere? And what about the myth almost everyone has heard, the one about frozen waste falling from the sky and crashing through someone's roof? Let's follow this all the way through, because the answer involves some surprisingly clever engineering. First, let's talk about that sound, because it's the key to understanding the whole system. Airplane toilets don't use gallons of water the way home toilets do. They can't. A commercial jet might carry over 100 passengers on a 5 or 6 hour flight, and if every flush used 1.5 gallons of water like a home toilet, the plane would need to carry an enormous amount of extra water just for waste, which means extra weight, which means burning more fuel. On an aircraft, weight is money. So engineers had to solve a very specific problem. How do you clear waste effectively using almost no water at all? The answer is vacuum suction. Modern airplane lavatories use what's called a vacuum toilet system. When you press that flush button, a valve at the bottom of the bowl opens, and it connects to a sealed waste pipe that runs through the plane. That pipe is kept at a pressure lower than the cabin around it. The moment the valve opens, that pressure difference does the work. Air rushes in and drags the waste along with it down the pipe at high speed. That's the roar you hear. It's not water pressure at all. It's essentially a vacuum cleaner for waste, using a small rinse of blue, or sometimes water-based fluid, just enough to clean the bowl, not nearly enough to flush anything away on its own. This system was actually a huge upgrade from what airlines used decades ago, which relied on a blue chemical deodorizing liquid to break down and mask waste in a tank, using much more fluid per flush. The switch to vacuum systems happened specifically because it saves weight and water. Some aircraft still use a small amount of that familiar blue fluid for rinsing and odor control, but the heavy lifting is done by suction, not liquid. Now here's a detail most passengers never think about. How does a vacuum system work at both sea level and 35,000 feet, where the air pressure outside is dramatically different from the pressure inside the cabin? The plane's systems are actually designed to take advantage of that. At cruising altitude, the air outside the aircraft is extremely thin, so the waste tank, which vents to the outside air, naturally sits at a lower pressure than the cabin. That pressure difference helps power the vacuum. But planes also spend plenty of time on the ground, where outside air pressure is normal. So modern systems include vacuum generators, essentially pumps, that create the needed pressure difference artificially when the natural altitude difference isn't there to help. That's why the flush sounds just as intense sitting at the gate as it does in the air. So, follow the waste past that valve. Where does it actually go? It travels through sealed piping that runs from each lavatory toward a central, fully enclosed holding tank, usually located near the rear of the aircraft, sometimes underneath the cabin floor. This tank is not connected to the outside world in any way that lets material escape during flight. It's sealed. It holds everything from every flush, from every lavatory, for the entire duration of the flight. This is where we need to address the myth, because it's one of the most persistent flying legends out there. The idea that waste gets dumped from planes mid-flight and occasionally freezes and falls to Earth as so-called blue ice. Here's what's actually true. This is not standard airline procedure. There is no valve that pilots open over the ocean or over farmland to casually empty the tank. The tank stays sealed for the entire flight, no matter how long the flight is. However, the myth isn't entirely made up out of nowhere. In extremely rare cases, a tank valve can develop a leak, and if waste escapes and freezes at high altitude due to the extreme cold outside the aircraft, it can occasionally fall as ice and, in exceedingly rare incidents, reach the ground. These events are uncommon mechanical failures, not standard practice, and they're taken seriously by airlines and aviation authorities, specifically because they're not supposed to happen. The system is engineered to prevent exactly this. So if it's not dumped in the sky, what actually happens to it? This is where the process becomes almost identical to something you might already understand from an entirely different context. Airplane lavatory waste tanks are emptied on the ground, using a service that works a lot like the ones used for portable toilets at a construction site or festival, just scaled up for aviation. After the plane lands and taxis to the gate, specialized ground crews arrive in a vehicle called a lavatory service truck. This truck connects a hose to a service panel on the exterior of the aircraft, a panel most passengers walk right past without ever noticing. The crew opens the aircraft's waste tank valve from the outside, and, using the truck's own vacuum and pumping system, they suction out everything the tank collected during the flight. At the same time, in many cases, they also flush a bit of clean water and fresh disinfecting fluid back into the tank to help rinse it out and prepare it for the next flight. The whole process typically takes only a matter of minutes, which matters a lot because airplanes on the ground make airlines no money. Turnaround time is everything. From there, the truck transports the waste to an airport facility designed specifically to receive it, where it's treated and disposed of according to standard wastewater regulations, similar in principle to how municipal sewage is processed, just handled through the airport's own infrastructure rather than a home's plumbing system. Now, why go through all this trouble instead of just using a normal toilet system? It comes back to the two biggest constraints in aviation: weight and pressure. A traditional gravity and water-based toilet needs a lot of water, needs consistent pressure, and doesn't work well in an environment where the down direction can shift subtly during turbulence or banking turns. Vacuum systems use minimal water, work reliably regardless of the aircraft's orientation, and can move waste efficiently even in short bursts. It's a solution built entirely around the unique demands of flying, not a copy of what works on the ground. There's another detail people rarely consider. The entire vacuum waste system has to be reliable at extreme altitudes, extreme temperature differences, and constant vibration for tens of thousands of flights over an aircraft's lifespan. Airlines maintain and inspect these systems regularly, precisely because a malfunctioning lavatory can ground an aircraft. It sounds like a small, forgettable part of the plane, but from a maintenance standpoint, it's treated like any other critical system. So the next time you're on a flight and you hear that loud, almost alarming flush, you'll know exactly what's happening. You're not hearing something broken or aggressive. You're hearing a carefully engineered vacuum system pull waste through sealed piping into a tank that will stay closed until the plane is safely back on the ground, where a ground crew, using equipment built specifically for this job, empties it out just like you'd service a portable restroom, just built for a machine that happens to be flying at cruising altitude. Nothing drops from the sky under normal operation. Nothing lingers on the plane longer than it has to. And that dramatic sound isn't the system malfunctioning. It's the system doing exactly what it was designed to do, using the smallest possible amount of water to solve a very big engineering problem. And that makes sense. If you enjoyed pulling back the curtain on something you've experienced 100 times without ever really understanding it, subscribe to That Makes Sense. We're always looking for the next everyday mystery to explain.